Okay. I don't know if you can hear me. I think maybe I'm back. The microphone shows the same thing. I see sound in OBS. I will have to get a new link. Let me get a new link. Twitch, you might be able to still see me. Back to here. So YouTube link is going to be different. Unfortunately, anybody who was watching on YouTube, it probably crashed for you, and I don't think I have a way to get connected back to the old stream. So unfortunately, we will have to jump over to the new link here. There's that. Drop that, remove. And maybe, let me check one more thing here. Can I let's go here. Comments. I'm not sure how to get to the comments. This link. Okay. Close this, close this. We're back here. This is muted. We are back here, but we don't need this open. Almost there. This should be paused. And the chat. Let me get the chat back and then we're ready. Okay. Okay, sorry about that, folks. Basically I think what happened is my USB bus died, basically. All of the things that almost all the things that are plugged into my computer, like mouse and keyboard and microphone and camera, are all plugged into a big hub. Well, most of them are plugged into a hub. I have a different hub as well with some other stuff plugged in, and basically everything stopped responding. Everything that was plugged into that hub just disappeared. I couldn't use the mouse or the keyboard anymore. I think the microphone stopped working as well. Probably the camera stopped working as well. So that is what happened right there. So we will get set back up and see where we're at. You might need to type continue when you connect, or it will hang the USB bus. That does sound like what it did. So let's get back to where we were, and then interestingly, these are old. It's like it didn't save where we were at here, which is interesting. Continue. CircuitPython was stopped when GDB was connected to it. So that was this command. So I would need to put continue as a GDB command. Means it wouldn't be responding to USB requests. You want to hit continue and let it run until it crashes, and then it would stop automatically. GDB command. So we'll see if, hopefully this won't happen again. Of course, if it does, I'll come back again, and unfortunately, I think we'll have to have a new link again. I would type continue as soon as I get into GDB, basically. So we're going to go, so I'm going to step through these steps. We're going to go to this window. We're going to run this JLink command. That's going to say waiting for GDB. Then we're going to come to this window. We're going to run this command. That's going to hopefully put us into GDB. Then we're going to run this target. And then after we do that, we need to type continue. Type continue. Okay. Okay. I'm going to give that a try. And if I disappear again, I'll be back again. But fortunately, that's all I can do is hope and open try. That's happened to me before, so I'm not sure if it's it happens to me occasionally. So I'm not sure if it's related to all this stuff or it's just my computer being kind of weird, but so we're going to run this. This is waiting. We're going to go to here. We're going to target the elf. I'm going to copy the target. Copy the target. Oh, I can do C instead of continue. I'll do that. Copy the target. Let me put the chat back up as well. Also, I didn't look. The stream, yeah, okay, everything looks good on the stream, I think. So we're going to copy this. We're going to go to here. This is going to start it going. Enter. I'm going to do target. I'm going to do C, continuing. So one thing is I am back to not having these. My mouse is still working, so that's good. CircuitPy just came back. Starting target CPU. So was I in the right directory? Yeah, I was in the right directory. Don't worry about the question marks. It means the point where it stopped was not in the symbol file. I see. Okay. That's fine. Thank you. So we're continuing. So at this point, if we could make the Metro hard crash, then at this point we could do that like maybe BT, but we're inside of continuing. Now go to the REPL. So that's the thing is I'm not sure I have a great way to make it fail on this one. Oh. Yeah. Because I think this one does not suffer from the same problem of that NVM thing. And I don't have the breakout soldered on the feather, so I think what I have to do real fast is solder wires on the Pico. So I'm gonna do that because I can definitely make the Pico fail, but I don't know of a way to make the Metro fail. But I think we got the steps that we'll need on the Pico set up here. This shows me how to get these connected. So I'm going to solder these 3 wires, and I'll be right back real fast. And we're back. And we have these soldered now. Let's put the camera. Very far zoomed in. So we're basically going to be switching off of the Metro to the Pico now. I got 3 wires soldered on these 3 things. It's not going to want to focus if it's that close, basically. Could really use, let's see. Okay, that's probably the best. So I've got these 3 soldered on now. Doesn't want to focus exactly on it. I'm going to take a closer look at them. Okay, yeah, they're not the prettiest solder job I've ever done, but try to be quick. They are all soldered. They're not jumped to each other. So that's what we got. So the next thing is I'm going to take the feather out. I'm going to plug this breakout in. I'm going to face it towards me, I think. And so now I need to figure out the right way to wire this. Back to the show. Looks like we need Python. Okay, let me catch up a little bit. Okay, I saw this part. Go to the REPL, make it fail if it helps. If you create a display.io display, release it, and then create it again. Crashes. Yeah, the nvm command does work. Debug in RPy4. Can I get Raspy still? I'm not sure what that is. Lib Raspberry Pi. Flavored Flux sounds pretty fun. There we go. Need Python 2. Okay, so we're caught up. So I think what I'll do is let's get these things killed again, right? So after I do continue, how do I get back to the prompt? Because the prompt is what I used to quit last time, but now this is like inside of continue and it's not running. Like I don't think I'm actually at the prompt anymore. Control C. Thank you. Okay, yep, this got us to here. So we're gonna go quit. That's what we did last time. Yes. Okay. Here, this is closed. I'm gonna undo this one too, shut down. Okay. So now we will plug in the J-Link to the breakout. I'll unplug it from the computer while I do this, I think. So we'll unplug this. I'll unplug the Metro. I will take this header thingy out. This goes this way. This will get plugged back into the computer, but we do need to connect some wires to this, I assume, right? So ground, we probably will need to connect. And of course, we're on a Pico, which we can't see the pin out of. Pico pin out. And I don't remember which ones are grounds. I think it's like every 3 or 4 or something like that are grounds, but do not know off the top of my head, and I don't have one of the fancy little header thingies. So, okay, 3 from the end is ground. SWD, SWC, and power. Okay, so ground is in the middle. So my green wire is pretty good for ground. I use green for ground sometimes. So we're going to go from... So actually, yeah, we don't need to use the ground on the side. In fact, we can use the ground that's on this, so that makes sense. So we're going to go from ground on the Pico to ground here. And there's actually a couple of different ones. Does it matter which ground I use on this thing? This is J-Link breakout. This is this. Does it matter which of these grounds I use? This one says ground D, it looks like, or 0 maybe. Oh, hey, there's another guide for this. Not much about wiring. Okay, this is what we would do if we wanted to do it on the feather. Which is definitely not as convenient as the ones on the end. 3 on the end. But, so one of those 3 on the end is ground, the middle one. Ground is ground. But then this has ground here, and then this ground with an extra D. Does it matter out of any of those? No? Okay. Ground here. And then SW, so we are which way around? We are this way. I'll turn it to match. So to the right of ground when we're in this orientation is SWDIO. SWIO, I'm guessing. Versus SW clock. So we have SW, oh, clock here. Clock here. So I'm guessing SWDIO goes to this one, SWIO, and then SW clock to clock. So right side SWDIO, yellow in my case, to SWIO, clock on the left, to clock on the breakout. So basically we only have one ground, SWIO and clock. I don't have NC or SWO or key, or do I need VREF? Is that supposed to be power from Pico? I do need VREF. Pico, just 3 volts or the USB one? Do another jumper. Big 3 volts, which is 1, 2, 3, 4, 5 down. Try to get the camera going here as well. 1, 2, 3, 4, 5 down. Gonna double check. 1, 2, 3, 4. 5th one is 3 volts out. Four blanks. 5th one's plugged in to VREF. Oh, are you kidding me? This doesn't go far enough. Okay, we'll get the long one. One, 2, 3, 4, 5. 4 empty. 5th one plugged. VREF. This corner. Okay. We are wired up. I switched off the camera again, but there we are. Shuffle this stuff around a little bit. So Pico, plug it in. J-Link, plug it in. Okay. Both of those are plugged in. And I should probably not have CircuitPy, I think, right? Because when it boots through the J-Link, it does its own thing. No, I do still... Oh, but it's none of it's running yet. None of it's running yet. So that makes sense. Also, this thing doesn't reload sometimes. Yeah, we do actually have CircuitPy. So now we... Yeah, no smoke, which is a good sign. We will go here. Back to this one. Oh, what was that? 1 second. Okay. Heard Henri cat noises from the next room over. Does not seem like anything went too bad over there, though. Okay, so one thing is we don't have an elf for the Pico. And I kind of like the idea of having the elf, because that seems like it's giving some more of the useful data. And I will need a different... I do need to do the different MCU model, that's true as well. I'm going to go back here, Raspberry, ls build. So what was that? You taught me this just a minute ago. Make board ... clean, whoop, clean all? No. All, just clean all. No. Oh, we do still need to name the board. Sorry. Board and Pico. Pico. And this has to be capital. Now we're there. Okay. Oh, does this? Okay. I think I get it now. This runs the clean and the build. Seems like. While that's working, also Pico is difficult to flash, right? Because it doesn't have a reset pin. Which pin is reset? Run? Is it run or 3-volt enable? I think it's run. Let me look at a different one of these. Run pin, okay. So I'm gonna do this. Ground is 3 down. 1, 2, 3, ground. Reset is like in the middle. So from 3 volts out, it's 1, 2, 3, 4, 5, 6th one after 3 volts out. 1, 2, 3, 4, 5, 6th one after 3 volts out. It did just reset, I noticed. Let's do this. Oh. Hmm. Hmm. I don't know why that doesn't want to connect, but we are gonna do this. I'm gonna try to double tap to go to bootloader. Nope. Does it double tap or do I need to hold the button? CircuitPy again. Hold the button. Yep, that is right. Thank you. Okay. This built? Yes, okay. So, 2 ports, Raspberry, this, firmware. Oh, this is not running. This is my macro pad that I use for copy paste and some other stuff. Paste. Yes. So I am going to have to get Tio connected because that's how I'm going to get to the REPL. So hopefully it will just connect when it comes back. Okay, we're back to CircuitPy. Ugh. Device file is locked. Did I do it in here? Aha, okay, I did it in here. Yeah, that's fine. We could do all 3 in here. That's even easier, actually. We have REPL. We have these 2. Okay, so we're going to need these commands again. And we will need to change this. So this is the next question. What do we put for device for Raspberry Pi? Pico. RP2040 M00. This also has a different speed. But also this person's having a problem. They're using a thing called ozone, which I'm not. Would I need speed 1000? See if there's one more. Is there another resource? This is a PDF that says we support it, but doesn't have docs. Okay, we'll try it without speed. We basically have the same command, but with RP2040 M00. We're gonna go to here. Can I? No, I guess I can't. Okay. This is my REPL. So Paste this. Okay. No. It does say interface speed 4000. So maybe it needs to be at 1000. It found voltage. Cannot connect. This wasn't running. Maybe we need speed. Is it dash speed or dash speed? Whoops. Did I go off of that page? Yeah. Speed 1000. Dash speed. I got the same thing. So it goes through all of its stuff. It says connecting. It gets connected to the J-Link. It finds the voltage, which I think is coming from the Pico. But then we get check power, connection, and settings. So I have green is ground in the middle, connected to ground D. Oh, my camera's dead now too. There we go. Green is in the middle, connected to ground underneath this ribbon cable. This is 3.3 volts, which is the 5th pin down. 1, 2, 3, 4, 5th pin down. It's connected to VREF. I'm gonna try the other ground. I'm kind of weary of this because this one ground is the only one that it has this other. It's different, right? It's ground D. I don't know. Weary of this. Yeah. I'll do the one next to it. Call it superstition or whatever, but do that. Let's try this again. Whoops. I'm going to do it without speed first. Okay. Yeah. Ground is not ground, is ground is ground. Ground is a little bit different on one ground. D-like diode has a Schottky diode on it. 3.21. We got 3.22 last time. So it's pretty close, but it is a little bit different. And we got to here this time. Yes. Okay, so now we do this command with our firmware. And then we do our target. I ended up doing this without speed. I'll leave this here in case we need it later. This, I'm going to copy these in here so I can grab them from other in the future. Raspberry. Okay. Build this. Yep. Firmware.elf. So I'm going to paste this, but I'm not going to run it yet. I'm a little superstitious of this one as well, since it wrecked all my USB a minute ago, or my USB got wrecked at the same time as I did it. Put it that way. So I'm going to copy this, that way I'm ready to run it, and then I'm going to do a C also again, just like we did last time. So we're going to run this, then we're going to paste target, we're going to run that, and then we're going to do C. This is waiting, yes. Run this, paste, okay, C, panic. Continuing panic. But we're connected. Maybe that's just because we don't have any code running, like CodePy is empty. Maybe this is what we expect. BT. BT. Hardware endpoint buffer. So we got hardware endpoint transfer start. USB. Task doing background. Callback. Supervisor run. Standard in RX read line. Friendly REPL main. Crashed in the USB stack. But I think we are disconnected. So, but this is not the USB serial. This is not the NVM crash though, right? This is a different thing? Maybe I shouldn't have done C yet? There's a timing crash. Try monitor reset. Resetting target. Okay. So do I expect CircuitPy to come back? C first. Okay, we didn't panic this time. And we got CircuitPy. Okay. We found another... We found a different hard crash accidentally, maybe? Possibly. But now we should have REPL. REPL. Finally, we can run this. We can find it. I don't think I need this one. This was for the Arduino 0. This is the page I'm on here. I don't think I need that. This I already did a while ago. I don't need this. J-Link. I don't think I need this. This is the issue. Probably only when connected. Yeah. I could believe that. Okay, we're not moving this. Import print. We'll print anyway. It should be all F's, I think. Yeah. Save. And of course it worked. Read. We got them back correctly. Let's just save it again. Well, let's look. Did we see anything interesting in here yet? No. We need it to crash. Try it again. There we go. Now we crashed. So now BT. No. Control C? No. Yeah, Control C and then BT? Yes. Let me make sure this has focus. Control C. BT. Hardware alarm IRQ handler, reset handler. So we tried to reset and it failed. Is what my guess is. Reset it and set a breakpoint in the fault handler. I'm willing to try that, but I have no idea how to do that. Try list. No symbol. Did we do the firmware F? We did, but it does say no debugging symbols. So maybe it does, maybe it would help to go debug 1 when we build. Doesn't know where the source is. Debugging guide should have an example. Break in hardware alarm IRQ handler. Make breakpoint. Did I spell it wrong? Function. Break space in space HARDWARE underscore LARM underscore IRQ underscore handler. No in. Make breakpoint. So we should do no, probably, right? Make breakpoint pending on future shared library, because we're not going to load that because it doesn't exist. I think we want no. We want break hardware alarm RQ handler. Okay, now we have a breakpoint. So we make it crash again. The monitor reset, will that reset the board? Up arrow should work. Oh, nice. Yeah, I retyped it again. I could do up arrow and erase in. That would be, yeah, up arrow is nice. Monitor reset, resetting, resetting. Continue, right? We need continue, and then we see CircuitPy. Yeah. I'm getting this. I'm getting the hang of it. Oh, this was the wrong one. Just as I say, I'm getting the hang of it. Hopefully typing a C randomly into this one is not a problem. But maybe it is. Breakpoint reached. So one thing is I didn't ever do the NVM thing again. We're still not back on TO. It broke already in the IRQ handler. Because it's getting called all the time. IRQ handler is the thing that gets called a bunch over and over. And we put a breakpoint in it, and it got called, and it broke there before we actually got to crash. So should we try reset handler? Clear it? Clear it like Control C, and then, oh, clear one. Clear one. Use the file command. Is there a space? Yeah. No symbol table loaded. Use the file command. Yeah, no worries. Like, honestly, you guys are helping me out a lot, so no need to be sorry about anything. I would not have even gotten this far without the help from all of you folks, so really, really appreciate the Shippu and AT Makers Bill and everybody else helping me here. Can't remember the command for clearing a breakpoint. Maybe we can see if we get a little Google foo here. This is a GDB command. GDB clear breakpoint. Help. That's a good idea too. We have help. We don't need the internet necessarily. Breakpoints. Breakpoints, help, enter, help, breakpoints, catch, set breakpoints, catch, help breakpoints, we got that one, catch load, return, is it going to print more? Yes. Clear. So maybe it is clear. Maybe it needs at a specified location, maybe it needs that hex. Could it be clear and then this hex value? Oh, okay, clear in the name. This one. Copy. Let's go Q? Q is quit help, right? Yeah. Clear. No breakpoint. Disconnected still. So maybe by using help or doing something we did here, we made it go away. It no longer has a breakpoint there. This might have actually cleared it even though it printed all this stuff. Yeah. So let's try going back to this. Yeah. Deletes all breakpoints. Delete breakpoints. Auto display. So I think if we scroll up and copy the other function. This one? Break. Or a different one. I guess I did up to find it, but. Okay, we do have 2 now though, right? This said breakpoint 1. Now I do have 2. What did I do before that? List. BT. Continue. List again. Still no symbol table loaded. Reset handler. So try set a breakpoint in reset handler. Break. Delete what we have. So is it delete some breakpoints? So this is kind of ambiguous though, right? Delete some breakpoints. Do I need to specify or just delete breakpoints? Delete all breakpoints. Okay, yes. Okay. And now break reset handler. But this does still say breakpoint 3. I would kind of think it would reset to 1. Maybe it doesn't. Maybe it always counts up. So do we have, no, we don't have REPL because we need to go continue. Okay, hasn't crashed yet. Set a breakpoint in hardfall handler. I'll try that one next. Continue. I do still not have CircuitPy Did I skip a control C? Not certain we have a stack crash. I think we have a loop where it's stuck in the interrupt handler. Might have to wait while the loop hits it. Monitor reset, right? Reset monitor. But we need control C too, right? Because I need to get back to here. So resetting, but I need continue again after reset, then C. Okay, yeah. So reset and then continue. Always reset, monitor reset, and then continue. Gotta remember that. And then this is just telling me that I have a breakpoint set. This is not telling me that we hit the breakpoint though, right? Or is it? It broke immediately. We did hit the breakpoint. Okay. So we need to probably try this other one, hard fault handler instead. So we can delete the breakpoints again. Delete breakpoints. Type BT. Reset handler. Question mark. Delete breakpoints and then do hard fault. Okay. Delete breakpoints. Yes. Break. Hard fault handler. Hard fault handler not defined. Would it be an underscore between hard fault? Or do a future one? Maybe we just don't have it yet? That can't be right though, right? We would have it. Lowercase h for handler? Doesn't look like. Debug one. We could do that. So we'll do no. We'll do quit, because I think we saw earlier that we need to have all this stuff disconnected in order to install a new UF2, which I think we would have to do, right? Yeah, if you're heading out AT Makersville, I really, truly appreciate all the help that you gave me. I honestly, again, I know I said it before, but I would not have gotten even this far without yours and Deshipu's help. So huge thank you very much for all the help that you've given me here. Debugging with the SAMD21 GDB micro trace buffer. Oh, okay. Okay. So we'll make with debug 1. We'll close this also. We got our CircuitPy back. We'll just use this terminal for making ports, Raspberry. So I'm gonna go ls make board. I'm gonna paste. But it doesn't need build though, so maybe I shouldn't have. Clean. And then, was it capital debug 1? And then while that is working, we're going to reset the Pico again because we need to go back to bootloader. That's these two and the button. Reset. Try not to let them touch. Okay, we got bootloader. Building. I think is there like one day I discovered a different flag you could pass and use more cores or something and speed up the build? Maybe I'm thinking of something else. Whoops. It was pretty quick on this computer, truthfully, though. My old computer I was building inside of a Linux VirtualBox, J8, okay. My old computer I was building inside a Linux VirtualBox, and it took a lot longer. It was like 2 or 3 times the build times. I did do a make clean also, which I think makes it take longer. You don't do a make clean between reuses and stuff. So we got this. So build Raspberry CP this to here. Hard fault. That one is specific to SAMD. Okay, so we got back to CircuitPy. Does it show debug in here or anything? Doesn't look like it's any different. So now here, start JLink. Target. Okay. And we're not gonna have CircuitPy right now? Or we do? We don't. But that's because this is like pausing it. So it's, see here, and we got a panic. But this looks more like unrelated to NVM again, right? This is maybe like what we saw before. EPDS was already available. So do we want to just try again with monitor reset? Continue. Okay. Yeah, I think this maybe just happens sometimes, right? We saw a panic before. We didn't have as much here, but that's probably because we didn't have debug build, right? So now that we have debug build, it's panic, and it actually tells us something that might be useful if we knew what any of this meant. So we're back to CircuitPy. We could go back to REPL, try to make it crash again. Yeah. So maybe that speed 1000 would make it not do that part. Maybe I should try that. Let's do this one more time, And if we kind of get the same thing again, then I'll try that speed 1000 that we saw on that other page. Maybe that will stop it from crashing when it connects. So we want the GitHub page, this one. Paste here, read bytes. Oh, okay, that's just the speed, communication speed for the protocol. So that may not help then. We are on Fs, we're gonna copy this. This protocol is similar to SPI. Okay, so same as last time actually, we succeeded the first time. And our bytes are there, but if we do it a second time, we succeeded again. That's new. Let's try a different. That's a new wrinkle. Yeah. Let me try one more time. If that doesn't work, I'll go do the steps Nerodoc put on that issue. Yeah. We're just gonna succeed all the time now. Okay, what did Nerodoc say? Plug in the board, connect to the REPL, get the prompt, open, modify, and save CodePy, then go to the REPL and do this. If it works, repeat from step 4. CodePy is empty. Modify, save. And we're in the REPL, so it won't reset. We already had some of this imported. So I guess now we'll just try this part. There we go. So that's interesting. Saving CodePy. Well, yeah, the two differences were only 1 byte and saving CodePy. Or if that's a clue. So here, so if we do Control C and then BT, do we expect a backtrace? Still, I'm a little unclear on the idea of continue. Continue is like, what are we continuing? Is it, I guess because it automatically pauses and we need to continue to like unpause it basically. Data CPY. So that sounds maybe related to NVM. Right? Data copy sounds like it could be copying our bytes that we passed it into the NVM, but I don't know where this stuff is at. Can we look at that file? I'm not sure. Is that SDK? Is that in here? I guess it looks like it. Go standard link. Oh, no, this is some kind of not text. Type BT. Let me highlight this. Okay. So this gave us one part, and then this gives us the rest. So that was our first one. Signal handler called. We're inside supervisor tick. That gets called over and over, though, I think, right? And then this also over and over. But more, right? So enter. Backtrace stopped. Corrupt stack. Yeah. Be a corresponding C file. So my guess is Pico SDK Is that added as like a submodule or something? RP2 common? Because this is inside the build, right? Raspberry Pi build, Raspberry Pi Pico, SDK here. So this is like a compiled one, kind of, maybe. Is there lib Pico SDK or no? Source? Source, was it inside a lib or source inside of where? Inside of ports Raspberry Pi? There's SDK here. Source. Common. Go standard link. There we go. Well, maybe. We have .s, but that's text. So, oh. Yeah, crt0.s. Okay, this was .s the whole time. Okay. 275. It's an assembly file. Sure enough, here's our data copy. And this BLO data copy loop So interesting, before I did BT, we got both of these. Data copy at this file, and then it knew that this line was BLO data copy loop. When I did BT, we got the same first line. We didn't see that BLO data copy loop. Timer C also, though. Is it worth checking in here? Should be able to type list. Oh, hey, look at that. So that probably list, I think that wasn't working before, so maybe that needs the debug build, my guess. And this is basically printing that part of the file. That's the same as this. We have data copy loop, these two things, data copy, this thing, and then I guess this is probably trying to call data copy loop. But I also do not read assembly, so. Okay, list does need this. So if we just do enter, this is going to be more of the file though, right? Line 2, yeah, this is just the next stuff in the file. Pico copy to RAM. So I feel like we have uncovered slightly more information, but I am not entirely sure what to do with the information that we have uncovered. It's definitely pretty far over my head. Oh, the stream cut out? Stream got ugly. So sometimes the internet blinks out for like 5 or 10 seconds and then comes back. My guess is that's probably what happened. I'll check a couple of spots. It looks like we might be back to where we were before, at least. So hopefully I'm back for the most part. So the problem is that CP code calls that. Try continue and Control C again. Maybe it'll land in a different place. We can do that. So if we're here, so continue and then Control C. 276. It is one line after. And list, I presume, would just print the same stuff that we see in this file. But that is interesting that it's one line after now. BT. Doesn't it support multiple threads like threads? There's the gone. Yeah, for sure. Thanks for hanging out, Dexter. Appreciate all the folks that are watching. So it's stuck in the loop. Like stuck in data copy loop and not making it to this line until I did the continue and that allowed it to get to this line. Yep, see you, Bill. Again, really appreciate all the help. Have a nice night, nice dinner, everything. Happy Thanksgiving if that's your deal. So I think probably the only real concrete thing I can do with this is paste it into here on the issue. And maybe somebody else will know what any of this stuff means. Hang the core. Well, yeah, hang the core is. That's definitely happening. Main is in SRAM and CRT0 is in flash. So CRT0 is our file. X LDR. Exit should not return. If it does, hang the core. Fall through into our hang exit implementation. This is an exit handler function. I'm going to take a quick peek around a little bit more of this file. I don't understand most of it, but that comment up there definitely seems potentially relevant. I'm curious if there's anything else. Provide safe defaults for exit and runtime init. Full implementation is usually provided by platform.c. Runtime init, thumb func, runtime init. If core 1 somehow gets into RT0 due to spectacular VTOR mishap, we need to catch it and send back the sleep and launch code in the boot ROM. Shouldn't happen. Should sleep in the ROM till the given entry point via the cross-core FIFOs, but it's good to be defensive. Line to allow memory protection, although this alignment is pretty much ignored by the linker script. That gets us to the end. Only core 0 should run the C runtime startup code. Core 1 is normally sleeping in the boot ROM at this point, but check to be sure. Assume there is at least one entry. Here we go. Reset handler initializes .data, clears BSS, calls runtime init, calls main, calls exit, which should eventually hang the processor via exit. Why does that make it sound like they wanted to hang the processor, though? Is that ever really a desirable thing? Debugger tried to run code after loading, so SSI is O3H only mode. This file is not too huge. I'm going to kind of scroll through and read the rest of these comments real quick. Header must be in the first 256 bytes. Flash builds, but immediately after the vector table. For no flash, the vectors are at 0x100 offset because the boot ROM enters RAM images directly to their lowest address. Bunch of these. Separated out for clarity. ISR breakpoint. ISR hard fault. Would this maybe be our hard fault one that's different from that one in SAMD? There a weak symbol for each ISR. By default, they'll fall through the undefined IRQ handler below. Can be overridden by C functions with the correct name. All default exception handlers do nothing, and we can check for them being set to our default values by seeing they point somewhere between ISR's start and default ISR's end. Yeah, see you, Deshipu. Thank you again as well. I really appreciate all the help to get me through this stuff. So have a good night, day, weekend, everything. Really appreciate it. Thank you again. ISR hard fault. Okay, and that gets us to the beginning. That's all of this file. So we don't ever see ISR hard fault in this trace. My guess is maybe that's not quite the same as that SAMD21 thing. So I think really what I can do is copy this information into the issue, which is not a lot. I can't do a lot to try and solve it, but we can add more details here at least. So let's do that, and then I'll probably wrap up after that as well. Go get some dinner, I think. So I got a backtrace of this issue from a Raspberry Pi Pico using JLink GDB. Not entirely sure what it means or what to do with the information I found, but here is a paste of the backtrace in case someone else a little bit more knowledgeable knows what is going on under hood here. Fix the spelling. Okay. So I'll basically just paste all the information that I know, which is not a lot again, but it's something. It's more than was here. So the first time we did this is when we got this. crashing. First thing, first backtrace is this. From there, use GDB command, make it continue. Received second backtrace, pointing to one line down. One line pointing to the next line down inside of CRT0.s. We'll put this. And I did a list inside of here. I think I'm going to copy all this and then cut out my list. Copy. Paste. Because this is just part of the file. And I'll also put where I found the file, which was Raspberry Pi SDK source. Found the file that it's pointing to at pointing at inside CircuitPython repo, pointing to at repo root / ports Raspberry Pi, ports Raspberry Pi SDK source RP2 common Pico standard link and there it is right there. CRT0s. CRT0.s. Okay. So one more thing I'm gonna try is we made it one line further after doing like a Control-C and a continue again. Maybe we could do the same thing one more time and maybe it will go to a different spot and give us a different backtrace. Because we just did list. I think I did Control-C and then continue, or continue and then Control-C. So if we go C again and Control-C, It is a different spot. BT. Only one this time, and it's 210. It's on BXR2 again. Which was... $276. BXLR. So I guess let's just keep chaining them on. I don't know how many of these are actually relevant, I guess. From there, I again used GDB command to make it continue and Control C again. Ended up with a third backtrace. This one is much smaller too. We have only one part. We have only one thing. Where did I start last time? Did I put the continuing? No. Basically put just this. That one didn't work. Okay, this is in the wrong spot. This is the end of this one. This needs to be outside of here. Entry point. So do we keep changing if we keep doing this? Continue, Control C? Seems like yes. But I'm not sure if all of these things are still relevant. This is on a BL ROM func lookup. C, Control C. Back to reset handler. I didn't do a BT last time. I should have done a BT last time. So these things we saw before. Reset handler. supervisor tick, and hardware alarm. Into here, but different line inside of here again. Platform entry for stack traces. So this one is not in that file anymore. We finally made it out of this file, I guess. Okay. So the last one we did was 210. We'll take all the rest of this. We'll paste that, and we'll leave it at that. I don't know if it's going to keep changing, but I have a feeling we're getting further and further away from stuff that would actually be relevant. But it is interesting that we eventually found one outside of that file. Okay, I'm going to post this, and I think I'm going to call it there as well. Post. So yeah, that was definitely quite an adventure. Again, for folks, if you missed the beginning, this was my first time diving into GDB debugging and using a J-Link to try to get backtraces from hard fault, like hard crashes. So I definitely learned a lot. Hopefully folks watching learned some as well. I kind of know the process now of getting set up to do this. It's like running this J-Link GDB server, targeting your device type, and then in your other terminal, you're going to run this GDB Pi. You can target your firmware ELF file, Once you get inside of there, you can do this target extended remote. This is pointing back to the port that this JLink command started serving on. Then from there, you can start, interacting with it with GDB. You can make your breakpoints. You can get your backtraces if you force it to crash. C for continue, Control C to break. Monitor reset to basically reboot all the way back to the beginning. I didn't even make it really to breakpoints here, but I will probably go through and read this page as well at some point, and maybe backtrace also in the next couple of these in the next couple of days here. Go through this and see if there's anything else maybe that I can do. Okay, so there's our delete, takes a number. See if there's anything else I can end up with a breakpoint in the right spot to find out something different. But that's going to do it for now. Again, I appreciate everybody who watched. Hopefully this was a decent enough replacement for Deep Dive. As far as I know, Scott's going to be back next week, so I'll be tuning into that when it happens, if so. And again, I'll mention one more time, if folks didn't catch the beginning, I normally stream Saturday mornings at 10 a.m. Central Time. So that is now about 15 hours from right now. So whatever time zone you're in, about 15 hours, like 7 minutes less than 15 hours from now, I will be back streaming again. I don't know for sure if I'll continue on with this or work on something else. I feel like I'm a little in the dark here, so I'm not sure how much more useful stuff we can get out of this. Maybe the breakpoints and the backtrace pages might be helpful, but I'm not for sure what I will work on, but that's when I will be back, is 10 a.m. Central Time tomorrow morning, about 15 hours from now. So tune in then if you are interested, and I will be on Twitch in the same place, Foamy Guy Twitch, and I always post the current YouTube links inside of the live broadcast chat on Discord. So you can go to the Discord there, and I'll drop the link in there right before I'm getting ready to start streaming. So I will see you all then. Again, thanks everybody who tuned in. For sure, extra special thanks. Again, I know I told it to both of them when they were here, but seriously, I would not have gotten anywhere near this far without the help of ATmakers Bill and Deshipu. So one more time, humongous thanks to both of those folks, as well as everybody else who hung out with me in the chat here. And I will catch you tomorrow.